For a science experiment, you need to electroplate zinc onto both sides of a thin, centimeter by centimeter copper sheet. You want the total zinc thickness to be 140 nanometers, that is 70 nanometers on each side, and you know that the charge carriers in the ionic solution are divalent. I have charge 2e zinc ions. The density of zinc is 7140 kilograms per meter cubed. So what are we doing here? We've got some sheet of copper, and somehow you make it positive. Let's pick that color. And so it starts attracting negatives to it from the fluid. And eventually you want to have built up, this is exaggerated for size, but you want to have built up a layer of zinc here. But of course, the fluid is on both sides, so it also accretes on this side. And they tell us that they want this to be, I'm going to say that the copper sides are, the sheet was L by L, and now there's thickness S. My diagram, I'll call it W. My diagram is terrible, by the way, because we know that the copper plate is 1 centimeter in size, and we want a thickness of 70 nanometers, so really it should be much different, but it'd be hard to draw. So what we're talking about here, though, is that we're going to end up with a block of zinc when all is said and done. We're going to have a block of zinc, and it's going to have dimensions L by L and width W, and therefore have a volume, which of course is just L squared W. Now, we know that the current is always the charge gained over the time taken, and the charge gained is going to be 2 electron charges times the number of zinc atoms that are pulled on. In other words, every zinc atom gives us 2 electrons worth charge. It's positive, really. I guess I should really call these positive. But we're getting 2e charge. Oops, in fact, I guess up here I should have said these were positives being attracted in. And we put negative on our plate. That makes a lot more sense. All right, so if we knew how many zinc atoms there were, then each of them gives us 2e worth of charge, and we take time t, which is actually what we're ultimately looking for. Well, how many zinc atoms do we have? Well, we would have the mass, the total mass we have, divided by the mass of one atom, which for ease, I'm going to call M1. That's the essentially atomic mass of zinc. But, and we can go a little further, let's go up here and go a little further, 2e over the time, oops, times the density of zinc times the volume over the atomic mass of zinc. I'm going to write that one more time here. We have 2 electron charges per atom times how many atoms we have, and the number of atoms we have is the total density times the volume over the atomic mass, because the density times the volume is the total mass, and each we divide by how many atoms we have. And then all told, we also have that we're carrying along the time. Of course, that really means we want to reciprocate this. We want to solve this for t, and we're going to get something like the time here is going to be 2e over the current times rho v over the mass. And after here, it is really just plugging in incredibly annoying numbers. So 2 every zinc atom has 2 times 1.6 times 10 to the minus 19th coulombs. And the current is given as, what is it? Whoops, it wasn't in the problem. I didn't copy it over from the problem. Apologies. Our current is given in the problem as 1.4 milliamps, so 10 to the minus 3 amps. Times the density of, times the density of zinc, which was given as 7140 kilograms per meter cubed, times our volume, which is going to be 10 to the minus 2 meters squared times 140 times 10 to the minus 9 meters, not squared. And then divide by the atomic mass of zinc, which you could look up, or I think eventually they'll give you as a hint, because why not? Anyway, turns out to be 1.09 times 10 to the minus 25 kilograms per zinc atom. If we do a quick reality check here, we have, oops, I'm sorry, I did not write my units here, coulombs per second for the current. So when we do it, we have coulombs over coulombs per second. So this is in the units of seconds. And we have kilogram per cubic meter times meter squared times meter. So that's kilograms over kilograms. This has no dimensions to it at all. If you then take out your plastic pal, who's fun to be with, and grind this out, you get something like 209.6 seconds.